Good afternoon, ladies and gentlemen. Good morning to our attendees from the US and overseas. Welcome to our webinar, the first webinar of Coventya in this series for this summer. Thank you for attending. Thank you for being with us. My name is Thorsten Kühler and I'm responsible at Coventya for the business development, and I'm welcoming you to the presentation by Christian Kaiser on specialty dry film lubrication of fasteners, an overview of current challenges and best practices. I hope you will enjoy the presentation. First, let me make some introductory remarks. I suppose that many of you know Coventya. For those of you who do not know us, Coventya is one of the world's leading manufacturers and providers of surface treatment process technologies with a strong focus on electroplating. Microglide is a company that is part of the Coventya group since something like nearly 3 years. And Microglide is a specialist company for lubricating fluids and grease-based for fasteners and many more applications. The presenter of today's seminar is Mr. Christian Kaiser, who is Managing Director of Microglide Company, and he is at the same time our International Product Manager for the Lubrication Product Group. I hope you will enjoy the speech. I hope you will take away something valuable for yourself. Maybe one or two remarks on the organization. Using the panel on the probably right-hand side of your screen, you can ask questions by typing them in anytime during the webinar. We will try to answer them in writing right away, or we will collect them and try to answer the most frequently asked questions at the end of the presentation. Please make good use of that. We are absolutely open to answer anything that you might want to know in more detail. So thank you very much again. And I would say, Christian, it's your time. Please shoot.
Thank you, Thorsten. And hello, everyone. Thank you very much for joining this webinar on dry film lubricants for fasteners, current challenges and best practices. I will switch off my webcam now so you can focus more on the presentation than on me. I will switch it back on again after this presentation so we can have a discussion and ask your questions. And like Thorsten said, please make use out of the option that you have to type in your questions in the chat area, and we will make our best to address those at the end of the presentation. Or you send us an email and we will get back to you directly. Thank you. So we will be talking about Microglide and the lubrication of fasteners. Why is it needed in general? We will then talk about the application and equipment side of lubricating fasteners, which is a very important chapter of this presentation. We talk about application hints and best practices, as well as which type of equipment should be used. And finally, we talk about the maintenance of the dry film itself. The last chapter of this presentation is about actual products and solutions from Microglide, and a little bit about the history of fastener lubrication and some attachments. So what's the job of fasteners? Is the initial question. Basically two things. A fastener must work, it must function, which is related to the coefficient of friction or the surface condition of a fastener, and it must last, it must not corrode, which is the quality. In 2018, Coventya took a majority stake of Microglide, and by that we bring together world-class corrosion protection from Coventya, world famous for zinc nickel, sacrificial cathodic corrosion protection, and now with Microglide we add specialty lubricants for special applications and in order to meet new requirements, which we'll be talking about in the next couple of slides. Microglide is a specialty lubricants company with about 50 50% of their business going into fasteners or on fasteners. And this is what we will be talking about today. You can see in the red box, Dry Film Lubricants DF series. This is what we will be talking about, and the sealing products DCP series, Dry Corrosion Protect. DF series is about lubrication and just lubrication, and DCP is combined products, corrosion protection and lubrication. Other areas of activities of Microglide are solid film lubricants, grease pastes, lubrication fluids, tribo tools, and other specialty lubricants, but this is not part of our discussion today. If you are interested in the other sections, please get in touch with us, and we are more than happy to get back to you and talk about your specific need. Going back to our subject of today, lubrication of fasteners. So what happens if lubrication fails? If we do not have the right lubrication on a fastener, we have all kinds of issues. The worst thing is that the connection will not last. It will not hold together. If the lubricity is too high or the coefficient of friction is too low, what happens is that the connection can open by itself through vibration, through temperature, or other external impacting factors. If the coefficient of friction is too high or the lubricity too low, we do not achieve a clamp force that we want to achieve. And the same thing can happen, the connection will break. Another thing that can happen if the friction is too high is that you end up having galling, or if the friction is too low, you can even crack the part because the torque was too heavy. So when we assemble a fastener, we apply a certain torque, and the vast majority of that torque is getting lost. About 40% is being lost with a thread, and about 50% is lost with head friction. And only 10% result in clamp force, and this is what we actually want. So we need to adjust the friction of the surface in a way that we get to the right clamp force with a given torque. And that's the purpose of dry film lubricants or lubricating of fasteners. If we talk about lubrication of fasteners, there are several types. We do have three categories: grease pastes, polymer suspensions, and anti-friction coatings, or bonded coatings, solid film coatings. Today we talk about the polymer suspensions, the dry film lubricants. This type of dry film lubricants are polymers, and they give you a coefficient of friction that is within the automotive specifications. The application for dry film lubricants is dip spin coating, and in some areas spraying. And the size of fasteners we are talking about is everything that is below M24. The other technologies that can be used for lubricating fasteners is for the most part for large fasteners and specialty applications. Again, today we talk about dry film polymer suspensions. Now, why do we talk about that? Fasteners are no new technology. Fasteners are around for decades, if not centuries. And you may say the development of lubricants for fasteners must have ended at some point. There can't be any new developments. Well, that's not precisely right, because with new technology at the end use, at the end product, like a car, we do have new challenges. Like, for instance, with cars, lightweight materials. The share of lightweight materials is increasing and will continue to increase. Think about the electrification of cars, the fuel consumption of cars, etc. So all automotive companies are trying to reduce the weight, and therefore we have new challenges with new materials. Also, another challenge is multiple tightening. Fasteners are used more often, so new standards, new coefficient of friction standards ask for multiple tightening purposes. And for that reason, different materials, different tribology properties, and a higher degree of withstanding properties for multiple tightening purposes is the reason why we still have issues and why we still need specialty, even more than ever, specialty dry film lubricants for fasteners. New assembly technology and new test standards increase also the need for specialty solutions. And this is why we say one size fits all days are definitely over, and more we see specialized solutions are required to meet high technology requirements. For example, Daimler released a new standard for their fasteners, MBN 10544, And the challenging thing about this standard is that not only we talk about different materials, steel, aluminum, and E-coat, but also 5 times multiple tightening. Now, the challenging parts, the extreme materials here are aluminum and E-coat. E-coat being relatively lubricious, and aluminum is pretty high in friction. And we need with the same coating to meet both materials. Steel is somewhere in the middle, that's kind of the easy part. But if we have 5 times multiple tightening against aluminum and steel and E-coat, we need to have a product that is giving us a high tolerance. Here we show some results from practical applications, industrial applications. A, B, C, D, E, and so on are applicators. And then we see the results of the coefficient of friction against aluminum in the top chart, and in the down chart we see results from 5 different applicators against E-coat. The product that we have used is the same, and the part that has been coated is also the same. So what is the difference? The difference is the application, the line, and the equipment that has been used. This is why it is very important to talk about the application and the equipment, as well as the lubricant. If we are not in the middle of this graph, we will not have quality coating. So it's not just the lubricant that is used and the parameters around the lubricant. We will talk about that at the end of this presentation. It is as important to have a close look at the application and the equipment. And this is particularly true for these new standards and new challenges we have just talked about. Now, there are a lot of parameters that impact the performance or the quality of a dry film lubricant coating on a fastener, and we will go over this list. It's like a checklist, and you may want to, if you're an applicator, you may want to go over this and review your own production procedure and see whether there's something in for you that you could adopt and take on. Now, the coating process at a glance is pretty simple. First, we fill the fasteners in a basket. We immerse the basket into the lubricant. We drain off the excessive material. And then finally, we put it in a spin dryer and spin off the excessive material and heat it for drying purposes. So it's just 4 steps, and you may think this is fairly easy. So why is there any issues? Why is there need for such a webinar like today? Well, the devil lies into the details, and we will show you in a couple of slides where we think what our experience is, you should have a closer look at. First, we recommend to preheat the parts before you go into the dry film lubricant. This is a best practice because most of the dry film lubricants are water-based, and water as a solvent has the tendency to contract at the surface if it's cold, particularly in the winter times in Northern Europe, but also in other areas of the world, like in the US. Monday mornings, wintertime, parts come from the truck, overnight transportation. They are cold. You will have no good penetration of the surface. So we always recommend to preheat it. One picture says more than 1,000 words. We call it potato hot. So it should be not too hot. It should be as hot so that you can touch it without burning. It's no rocket science. An applicable range would be 40 degrees C or 104 F up to 60 C, 140 F, plus minus. It's not rocket science, it's not scientific, but it should be pre-warmed. Another advantage with preheating the parts is that the drying procedure after the coating is more efficient because the parts will keep their temperature. How to preheat the parts? Just put them in the centrifuge and put them in the spin dryer, and that's it. If you have a plating shop and the coating of the dry film lubricant is subsequent to the electroplating, some companies still go wet into the suspension, into the dry film lubricant. We do not recommend that for several reasons. One is, again, the penetration. If you have a water film on top of the parts, you will have a dilution and you will not have the effective amount of lubricant at the surface. That's one thing. And the other thing is you dilute the bulk of the material of the dry film over time, slowly but constantly. And after depending on the surface that you're carrying through your dry film, after some hours or days, you will have a totally different concentration of the active ingredient, which will shift the performance of the dry film lubricant. Go in, preheat it, and dry. After the drying, we dip the parts into the lubricant and then take out the basket and slowly rotate the basket over the tank. This is in order to get rid of excessive material, which helps you with residues and too much remaining dry film lubricant on the parts and on the equipment. And it will also reduce the consumption of the dry film lubricant. We recommend to do it in a tilted position, depending on the parts, with washers in particular, and we recommend to have a bidirectional spin over the tank. This is the most efficient way on how to reduce the amount of dry film lubricant used, and the cleanliness of the parts is improved. Dipping and spin time. The dip time is not that important. Typically 10 to 20 seconds are sufficient depending on the parts. You just need to make sure that you have all areas of the parts being in touch with a solution. If you increase the dipping time, the coating thickness will not increase. So it's only about to have all the surfaces covered by the liquid. That's it. The spin time is the variable that you need to take into account for getting the parts dry. The spin speed is more important to take a close look at because the spin speed determines the amount of lubricant you have on the surface. If the spin speed is too high, you spin off too much material and the whole coating process basically was redundant. So the longer the centrifuge time, the higher the quantity of spun off material. Yes, but not so much. If it's more about the spin speed that determines the amount that is left on the part. Too short centrifuge time is problematic because parts will not be completely dry. If you look at the spin speed depends on the diameter of the coating basket. If the diameter is large, the spin speed must be slower and vice versa, because the effective speed at the outside of the basket will be even higher if you talk about RPMs, if you spin too fast. There's a lot of calculations and models, but as a rule of thumb for most industrial lines, an RPM of 200 to 300 is sufficient. The drying temperature is important. We do not recommend to exceed it to the max. We recommend to have ambient drying temperatures. 50 to 65, 70 degrees C is what we recommend. If you go higher than that, you will basically melt the dry film lubricant, which will have an adverse effect on the performance. We'd rather recommend for the drying to have a look at the circulating air. So if you have an effective air exchange and you convey the humidity over the centrifuge, this is much more effective than increasing the temperature. So you have a couple of options on how to improve your drying procedure, because the aim is to have them dry, the parts. You can increase the temperature, which we do not recommend. You can increase the spin speed, which we do not recommend because you lose your dry film lubricant on the parts, or you increase the time for centrifuge spin the parts. And this is actually the only parameter we recommend to play with. If the parts are not dry with a given temperature and a given spin speed, increase the spin time and nothing else, or improve the air circulation and put in a more effective ventilator. That helps you also to get the parts drier in a faster fashion. Looking at the baskets, which is one of the core pieces of equipment for the whole process, there are some old technologies still out there, and this is something we definitely need to talk about because it determines by a large extent the quality of the coating. Old type of baskets do not even have a perforation at the bottom, which is a problem because you kind of create a sump in the baskets, like you can see on this picture. And even worse, if you have a non-perforated bottom and you have a ring like this, you have really like a lake inside the basket. And what the operators typically do is they increase the spin speed to a crazy number of RPMs, like 1,000, if the equipment is able to do that. And if you spin it at 1,000 RPMs, there's no lubricant left on the parts. So the whole operation was basically useless. We recommend to have a basket like this with a conical shape that gives you comparatively a comparable spin speed for all parts inside the basket with a perforated bottom, so that you don't have this situation. Talking about the perforation, simple holes are problematic when you consider wood screws like this, for example. With sharp tips, they tend to attach to each other and get trapped into the perforation. With this type of smiling perforations, which is state of the art, you have two advantages. Less parts get stuck, and the other advantage is that the last drop is accumulating at the top, or sorry, at this point where the smiley in the middle of the smiley on the top side. This is where the last drop will accumulate. It has a tendency to accumulate here, and then you will spin off the most material, which helps you to keep clean your equipment. Filtration. You want to make sure that you don't have large particles in your dry film lubricant. You always need to take out large particles because they will attach to the surface and you will have cleanliness issues. So filtration is not meant by like plating shop filtration when we talk about microns, something like that. We talk about like a sieve only. We take out large particles. 120 to 240 microns mesh size is absolutely sufficient, because if you go below 120, you run into issues and take out the actual dry film lubricant, because the polymer size is pretty large and you can even filter them out. And another important thing to consider is never use a gear pump, because gear pumps have a high shear forces between the gears, and they will cut the chain length of the polymers. So always use a slow moving membrane pump like you can see here. There's no need for a certain solution turnover per hour. It's absolutely sufficient to have them very slowly moving. Be careful with the solution. Don't apply too much force for shearing to prevent shearing of the polymers. If you do not apply housekeeping, this is how it looks after some time. You will have particles floating in the solution. You will have heavy residues at the side of the tanks. This is what you want to avoid. And if you don't have an automatic filter system, you even can use a sieve to take out the particles, but never let the residues grow like you see on the two right pictures, because otherwise you will have particles on your fasteners. We recommend for that reason at least 2 to 4 times per year to take out the entire bath and clean it mechanically. Take a power wash, take brushes, use it mechanically, make sure that you have removed all the residues, all the scale on the tanks, in order to keep everything clean and proper. The baskets itself, they should be cleaned more often than that. The baskets, because they build up pretty fast with dry film lubricants. They also typically must be cleaned physically. Sandblasting, which affects which has an impact on the steel itself. Dry ice blasting is more sensible, but it is more costly because of the high energy amount that you need. Flaming of the basket and subsequent high pressure water spray is possible. And then finally, what modern lines do is they clean the basket after each and every coating cycle. Better than caustic soda is potassium hydroxide and a surfactant, and you need a high temperature. This will also help to strip the remaining dry film lubricant off your baskets. But this is only possible chemical cleaning if the scale is not too severe. In almost all dry film lubricants from Microglide, we have a Euv Tracer. And the job and the purpose of the Euv Tracer is to tell you, yes, the parts have been coated or they have not been coated. The Euv Tracer, if you look at these pictures, they are no quality indicator. The UV response will not tell you whether this is a good coating or not. You look here, this is the Euv Tracer. It's on a REM photography. It will sit in the thread, and it is not uniform, but that doesn't tell you whether the PE or the type of lubricant that has been used for the specific product is coated uniformly.
These 3 bolts are prior to assembly, and the left 3 bolts are after assembly. So you can see that something is happening with a lubricant and also with the UV indicator. We do not want to increase the UV indicator in the products because it will be bad for the friction. It will sit in the valley of the thread and it will increase the friction. So we don't want to have too much of the UV tracer in the products. Again, it's only an indication of yes, the parts have been coated, or no, they have not been coated. The solid lubricant content to dry residue is the most important analysis parameter. It should be checked at least once per day, or better, once per shift. How we do it, we see it in a couple of slides. It's very important to check that frequently. We have certain makeup ratios that we work out together with you. That is specified. We do a Ppapping with a series of different makeup ratios, like 1:1, 1:2, 1:3. 1 always stands for the product, and then the second number is the amount of water that we use for dilution. And this must be checked frequently. It's just a comment about Ptfe, which is a lubricant that is also being used, particularly for special applications. But generally speaking, we do not recommend Ptfe as a dry film lubricant constituent. There's only very little applications where we think there's a justification of existence for Ptfe. There are several reasons for that. Ptfe will settle down. It behaves totally different than other dry film lubricants. So you cannot determine or analyze it distinctively. You will always find a percentage, and you never know whether it's Ptfe or not. It's expensive. You need a special binder because it's chemically inert. The Ptfe particles are pretty large, so they will walk up the thread if you assemble it, resulting in a relatively low underhead friction in comparison to the thread friction. So there's a lot of reasons why, for the most part, we do not recommend to use a Ptfe containing dry film lubricant. The rule is the exemption, but generally speaking, there's, in the meantime, with new formulations, no need for Ptfe. Storage of dry film lubricants is important to keep it above the freezing point, because once they are frozen, they are basically destroyed. And the tricky thing about that is you can't tell the difference. The product will look the same, it will smell the same. You find the same amount of residue, but the chain length and the nature of the whole product will be different. So always make sure that you store it in temperatures above the freezing point. Bath control, basically you have 2 options, but we recommend an automated heated scale to determine the dry residue with an refractometer. You can check some of the products, but not all of the products. But more precise is this type of equipment you see on the left side. You run it at about 110 degrees C, not more. If you go way above 110 degrees C, which is just above the boiling point of water, for the American participants, excuse my Celsius units. So let's talk about the boiling point of water. Just be above the boiling point of water. Otherwise, it will fake it wrong concentration because the sample will create a skin on top. So the balance will not change, but it will not give you the right concentration. That's an important thing to know. Also very important is you have to make sure that when you take the sample, the whole bath is homogenized. It is steered well. Some of the dry film lubricants have the property that the solids will settle, precipitate, and then there's other formulations where they will swim up over time. So always make sure that you move and steer the tank before you take a sample. Ideally, take a slowly moving piece of equipment, like a paddle or something like that. Don't be too aggressive, slowly moving. Move it for a couple of minutes before you take the sample, and you can be safe that the results are reliable. And then the second parameter you need to check is the pH. You can either use a pH meter, which is preferred, or pH stripes. There are some pH stripes available with a very narrow pH range that will give you a precise number. And then finally, the quality of the coating itself and all the items we have been talking about so far go into that, is with a friction bench for metric screws. That's the only way, and it's very difficult if you don't find the right numbers, if you have fluctuations in quality, a big scatter, to trace what is the root cause for the issues. That's why we think that, particularly with new standards, go over this list and check whether you have applied the best practices out of our experience, and then make sure that this has been done, and then you have a very high chance for getting a good and reliable result with a low scatter in quality. For chipboard screws or wood screws or self-tapping screws, a torque meter is applied for checking the quality to determine the force in Newton meter. So this chapter of the presentation was about application and equipment, and this is basically true for all kinds of top coats and dry film lubricants, no matter who the supplier is. Now we go into the second chapter of the presentation and talk about the actual dry film lubricants from Microglide. First, a comment: when we develop a dry film lubricant, and as you have seen how important it is to have the right equipment and application, we work with a almost industrial centrifuge for developing a dry film lubricant. There's no point in developing a dry film lubricant with a salad spinner or with a lab equipment, with an inferior lab equipment that doesn't give you reliable results, because it's not only a single fastener that has to work, it is the bulk of fastener that has to work with a low quality scatter. You always want to have an as narrow scatter as possible. So we have this equipment which is about 80 to 90% at an industrial scale type of machinery. And once we are convinced with this machine, we talk with our customers, with our valued applicators, if they help us to finalize the development in a true industrial trial. That's very important. Now, what has happened with lubrication of fasteners? It all started about 60 years ago with organic type of waxes, carnauba wax from a Brazilian tree, to reduce friction and noise, particularly for wood screws. And then after the introduction of cordless screwdrivers, it turned out that one battery charge will last longer if the surface is lubricated. And this triggered then the development of first synthetic waxes with the aim of getting more reliable results, less film thicknesses, less head fill, etc., and even lower torque figures for these wood screws. Until today, this type of lubricants are still in use, which is kind of a problem because they have been developed for hexavalent chrome, and hexavalent chrome is like a piece of cake if you want to coat them. The adhesion is perfect. You can't do anything wrong with hexavalent chrome as an undercoat for dry film lubricants. Now, with the elimination of hex chrome in the year 2000s, particularly for zinc nickel, but also zinc surfaces, and also the introduction of stainless steel wood screws, the old generations of synthetic dry film lubricants is not state of the art anymore. And now with the increasing number of specialty applications like self-tapping or thread forming screws, we need even higher lubricity. And then finally, what we have been talking at the beginning of this presentation, new coefficient of friction methods and standards to meet the production reality, they call for more sophisticated technology. So in the past, hexavalent chromated zinc, then with the introduction of trivalent chrome passivates with a ban of hex chrome, the automotive industry triggered the development of so-called top coats, which combine lubrication and corrosion protection. Because the first generation of trivalent passivates were not as good as hexavalent chromated surfaces at the time. So what we see today is, no matter what the substrate is, zinc flake coating, zinc nickel, plus trivalent passivates plus a top coat is in many cases not sufficient. You have to apply a duplex top coat to get to the right friction, or you apply a first aid spray like our DF977S, which is a spray that is approved by Volkswagen, and they can use whenever there's a batch of fastener that is not working, they use a spray to post lubricate it. So there's a lot of band-aids to make the fasteners work, which is not a good thing, because typically what's the idea that the fastener is working without a band-aid. And what we see more and more with new generations of standards and challenges is that we separate again the corrosion protection and the dry film lubricant we apply a duplex coating in a way that we apply a sealer, which is a pure corrosion protective coating, and then apply a pure lubrication coating on top of that corrosion protective coating, or sealer, how we call it. This is what we see more and more. Products from Microglide at a glance. First category would be the universal dry film lubricant. So whenever you want to be in the automotive window of coefficient of friction 0.1, or depending on the standard or higher, this type of lubricants can be used, or for wood screws or for other applications, whenever you deal with several types of different parts. Generation 1, like mentioned on the slide before, is our DF911. It's designed for hexaval and chrome. It's not state of the art anymore. We always suggest in the meantime Generation 2, which would be our DF921, which is a fundamentally different formulation that makes it able to work with all kinds of substrates: stainless steel, trival and passivated, zinc nickel, or whatever it is. Even plastic fasteners are coated with DF921. It is a wonderful universal dry film for all substrates and all applications. And then finally, in the category of universal dry films, there's our spray, the DF977S, that can be used over all surfaces. That gives you a coefficient of friction of 0.1 plus minus 0.01. And as a matter of fact, this spray is used as a calibration spray from a friction bench manufacturer, because when they deliver a new piece of equipment and they have issues with the reliability of their measurements, they say you apply the DF977S on top of your test bolt, and if you're not in the 0.1 coefficient of friction range, something's wrong. And then the second category is specialty dry film lubricants. For self-tapping thread forming screws, we recommend DF931 with a very low coefficient of friction, or which is very low torque figures, I have to say, for this application. Aluminum fasteners is an increasing trend in the automotive industry because of very good electrical conductivity properties. But you need a special dry film lubricant for aluminum, because aluminum is a very nasty material when it comes to friction. If you want to prevent galling, you need a specialty dry film lubricant. For large dimension fasteners, we have a product that is able to withstand post-rolling purposes. So if the thread has to be post-rolled because the dimension is too large when it gets impacted during tumbling, this is the right product you want to use. For phosphated fasteners as an oil replacement, we have a product, DCP 9300. It gives you reliable results across the bulk container where you store your parts. It is dry to touch. It provides a good coefficient of friction reliably, and it's not messy. For zinc flake coatings for special purposes, there's DF903. In case the curing temperature for the top coat is too high and the scatter of coefficient of friction is too high, you can narrow it down with the DF903. For lock nuts, where you need a very low coefficient of friction to activate the lock mechanism, DF941 with our product. For drilling screws, 931, and many, many more. So there's a lot of applications out there, specialty applications, where you really need a tailored solution. As an example, a case study with our DF931, which is used on self-tapping screws. We have tested competitive products. We have tested competitive products top coats with the DF931, and the result was just pure the 931 on top of a passivated zinc nickel triangular fastener provides the lowest torque. And as a surprise, the only top coat that, in case you need additional corrosion protection, that worked was DCP 9000 from Microglide plus the 931. The other top coats increased the friction over the torque limit that was given. Here is an overview of our products and examples of applications, areas of uses. This is an orientation that helps you to identify the right product. You can see our universal dry films have a lot of applications that you can use them with. It is an orientation for you to figure out which product could be used, but it is joint effort to come up with the right product and the right parameters, and we are here to consult with you, to help you, to make samples for you. So whenever you have a part or an application you have issues with, please get in touch with us. We are happy to consult, we're happy to code samples for you, do the testing, and then develop a method together that gives you the right results that you need. We have products that can be used over all surfaces: stainless steel, zinc, nickel, phosphated, titanium, aluminum, zinc flake, plastic, whatever it is. If you have a challenge, please get in touch with us and we are happy to support you. Our products are approved by well-known automotive companies, as well as fastener companies, as well as companies that are in the area of construction and wood applications. Here's a chart with all the approvals. You can find all that on our webpage. A few comments about that I will tell you in a second. So we are approaching the end of the presentation. Equipment and application is as crucial as the drive and lubricant itself. And with modern assembly techniques and modern standards, this is even more important and require tailored solutions. There's new challenges with multiple tightening and new materials. And this is all no rocket science, and we can make everything possible, but a few important considerations have to be taken into account and follow thoroughly in order to achieve reliable results, and we are there to help you with that. So if you have any questions about drive and lubricants, about corrosion protection, about samples and Ptfe, and about equipment of your coating line, please get in touch with us. We're helping you. You can find a lot of useful information on our website, www.microglide.de. For instance, our catalog for DF and DCP. That's not only a product catalog, it also contains application details, best practices, chemical and physical properties of the products, analysis methods, maintenance, basically everything that has been touched in this presentation you can find in this catalog. You can download it with a link above. And you will find all technical information, all technical data sheets of our drive and lubricants on our website. It's all available for everyone. At the moment, it's available in English and in German, and we're working on translating it into different languages as well. So why Microglide? We have decades of experience. We are the only company that has drive and lubricants for fasteners as a cornerstone of the business. This is our core of the business, and we continue to develop and enhance our portfolio unlike anyone else in the industry. We have a full portfolio of specialty lubricants for almost all applications. We develop for you, so in case there's a challenge that you can't meet with a standard product, we help you to develop a product just for you. And we are a small company. We are not micro, but we are a small company. We belong to the Coventya group, which helps us a lot, but we are flexible and we hear your needs, and we are pretty fast in reacting if you have any challenges. We are available. With Coventya, we have a lot of synergies because of the corrosion protection side of the fastener. For example, we see also with multiple tightening challenges with different passivates. And with all the passivates know-how from Coventya, we really can work in a more sophisticated way to get to the right results with the right passivate that determines to a large extent the corrosion protection. And training and consultation, together we make it work. So we do not shy away from making our hands dirty to walk with you over the line, to do samples, to provide trainings. During Corona times, maybe better over the internet, but once this Corona is over, we are happy to visit your sites and to conduct trainings in-house. Our next webinar is about hex chrome-free plating on plastics technology for the automotive industry. Even though this may not be your topic, but you may know somebody in your company who could be interested in. It's July 3rd, so please feel free to forward. And if you like that type of webinars, we're happy to welcome you again back for July 3rd. And that was it. Now we have about 15 minutes for questions and answers. I thank you very much for your attention. It has been a pleasure for me to give you this webinar. And yeah, Thorsten, what do you say?
Thank you, Christian, for this nice, clear, and instructive presentation on the development and the needs for suitable friction-enhancing coatings for fasteners, for friction improving, I should rather say. You already said we have some time for questions. There were some questions that came in during the webinar. One question that came in I can answer right away. The presentation itself will be distributed to the participants by mail. Maybe you can allow for a day before it reaches you, but you will receive it. So here's another question that has just come in. The question is concerning the application of the Microglide products. It says that you have suggested on your slides to only increase the spin time to remove excessive lubricant. Why is it not advisable to increase the speed? Maybe you can explain that again.
So yeah, if you increase the spin speed over the maximum, you will spin off too much material and you will have not enough lubricant on the parts left. The temperature you cannot increase to limitless, because if you increase the temperature, what happens is you basically affect the performance of the lubricant. It will melt and it will go away also. So the only real things that you can play around with is the spin time and an effective heat exchange, if all the other parameters are in shape. We have seen new lines with state-of-the-art technology, but they simply had not a good air exchange. So you can't get the parts dry, even with the right temperatures and the right times. So make sure that you have a good exchange of air. This will help you to reduce the cycle time. Or if nothing else helps, and if you want to get a good quality, increase the spin time, even though if you lose a little bit of productivity. This is what we recommend. Spin speed, you can increase it, but you have to be within certain boundaries, otherwise you will lose too much of the dry film lubricant. Preheating the parts helps also to increase the drying time, because like I said, it will keep the temperature of the parts and it will help with drying. Also, the drainage after the dipping process is important. You can just add another couple of cycles, a couple of spins for draining off excessive materials. Maybe you can modify your equipment that you can put it into a tilted position to drain off more material. These are the things you can play around with. And if nothing helps, give us a call. We are happy to review your line and make our recommendations.
Okay, thank you, Christian. I think that just received a thank you from the participants, so it seems this has answered the question precisely. Another one that just came in is about if there is any experience about the heat loosening properties, especially the question is here, or as an example for the DF921. Is that something that where we have more data on?
Thermal loosening, you mean? So there are different standards for determining the thermal loosening of fasteners. So we need to look into the details what the specification is asking for. Please get in touch with us directly. I don't say that we will meet all thermal loosening requirements with a certain product, because it also depends on the type of fasteners. This is an issue that pops off or this is a requirement that is called more and more often, because the combustion engines are more sealed than in the past, so the temperatures increases in the combustion compartment of a car, and we need to take care about that. There are specific products in the combustion engine area that are more prone to this, like phosphated fasteners in the car, in the engine compartment, where we need to take a close look on thermal loosening. But some applications, we know that it is working, for others it is not working, so we need a different approach. But it all depends on the application and the actual part, and we always have to PPAP it.
Okay, thank you for that answer. There was another question, very specific one. Is there any field experience with the application of Microglide solutions for Conrod screws, so Pleuelstangen?
Yes, we do have experiences with that, but it's for the most part it's phosphated, and we apply our DCP 9300 on top of it. That gives you a temporary corrosion protection, and the newer generation of this type of sealants will help you also with thermal loosening, which is an important thing for this type of parts.
Maybe this is also something where we can go into deeper discussion later on and follow up. There was another question about the Euv Tracer and how it does influence the coefficient of friction.
Basically not, if you don't exceed the amount of Euv Tracer, which is why I said it's a very minor amount of Euv Tracer that's in the formulations. It's about 1% of the solid content is Euv Tracer. If you would increase that dramatically in order to get a better UV response, you would adversely affect the coefficient of friction. You would increase the surface friction of the parts, and we don't want to do that. So in the concentrations we are working with, we do not see an effect with Euv Tracers, with or without.
Okay, maybe here's another one that is interesting also for the larger audience. It's about the applicability of DF903 on zinc flake coatings. Is there a certain connection to a certain type or a certain provenience of the flake? Can it be used on all types of flakes, or is it dedicated only to, for example, Durkin or Geomet or whoever is providing?
It's again, it depends so much on the application, and what we have seen the customers that they are using it, we narrow the scatter of the coefficient of friction, and this is particularly a problem when the curing of the top coat is too high. This is when these applicators apply it on top, and please understand, we can't talk about the type of zinc flake or the brand of zinc flake coatings these applicators are using, but yeah, it's like a band-aid for zinc flake coatings. It can be a band-aid for zinc flake coatings if there is a problem with a too large scatter of coefficient of friction.
Okay, so one question that has come up here a couple of times, and I think it's important. This is why I would like to reiterate this, although I've seen that you have touched on it. Do we have approvals according to automotive specs for the Microglide products?
Yes, we do have a lot of approvals, and you can find it online, or if we go back a couple of slides, you can find here an overview, and we are on many more drawings. So yeah, and if you need to get help because you want to apply Microglide, or you have Microglide but you do not have an approval at one specific OEM or tier 1 supplier, you can always get in touch with us, and we're helping you to talk with the right people and do the PPAPing in order to get on that list. So we are really active with the OEMs and specifying entities, because it's just part of the supply chain. It's a requirement for the supply chain and global availability that to be part of the automotive in particular, but also other industries as well.
Okay. Another question that has just come in is concerning the application of Microglide products on aluminum joints and for aluminum fasteners. Is there any general recommendation? What would be the type of product that we would recommend for aluminum joints in general, or is that, as I suppose it is, also depending again on the specific type of joint and application?
For the most part, we recommend DF905 for massive aluminum bolts. This is the only viable dry film lubricant for aluminum, because aluminum is really a special material, and it tends to gall, it tends to create a very high friction, so you need the DF905. This is a very specific product only for aluminum bolts. If you talk about aluminum connections if you mean in aluminum or against aluminum, there may be other options available, but if you talk about aluminum bolts and nuts, it's DF905. Or DF977S, the spray we have mentioned. This can also be used for aluminum. Whenever you have very small fasteners, or also very large fasteners that cannot be applied in dip spin, you can use this spray, which is also available as bulk material. And so both products, 905 and 977, can be used for aluminum.
There's another interesting question that is just coming in. It seems to be, from what it looks like, it's from an applicator. Can it be added to other post-treatment liquids? I mean, is it possible to kind of use the Microglide product as an addition to other post-dips or post-treatment or sealers or top coats?
I'm not sure if I understand that question correctly. We have several applications where we apply a dry film lubricant from Microglide on top of a post-treatment of whatever nature, top coat or a sealer. We apply a dry film on top of that. If the question is whether we can blend and mix the chemistries, I would be very careful, and I would not recommend to do that, because we have developed the products in a way that they are working standalone. So please get in touch with us and explain your inquiry a little bit more precisely, and we talk about it. But Microglide is applied at the final layer for the most part, and we can deal with a lot of substrates and with a lot of different already coated substrates as well. But blending chemistry, if that was the direction this question was pointing at, I'm not sure about it. I would not recommend it.
Yeah, I think that was the idea behind it. Okay, and I would agree with your assessment. Anyway, as it seems we have answered most of the questions that have been coming in, I would suggest that we maybe close the meeting. I see that there are also some other questions of more specific type. For those cases, I would suggest that we will be getting in touch with you after the webinar. Please wait for it could take a day before you receive the copy of the presentation, and that will allow you to get in touch with us directly to discuss in more detail and more deeply any upcoming question.
Thank you very much.
Thank you. So otherwise, I'm only left to say thank you, and I suggest that we close this session for today. Have a good day. Thank you for attending, and hope to talk to you soon, maybe then in person. Thank you very much. Goodbye.
Thank you, Thorsten, and thanks everyone for participating. Stay healthy.